The discovery of polyester was made by Dr. J.T. Dixon and Mr. Winfield in 1941 in the laboratories of Calico Printers Association in Lancashire, England. In Britain, the manufacture of PET fiber began in 1948 by Imperial Chemical Industries. In January 1955, a large plant came into production with an annual capacity of 5 million kilograms, divided almost equally between filament and staple yarn. In the USA, DuPont Company began producing PET fiber in 1950 under the name Dacron. The generic term polyester was adopted by the U.S. Federal Trade Commission for Fibers, a manufactured fiber in which the fiber-forming substance is any long-chain synthetic polymer composed of at least 85% by weight of an ester of ethylene glycol and terephthalic acid. It is also called polyethylene terephthalate, or PET. Polyester is a polymer which is made through condensation reaction taking place between two molecules, and linkages of molecules occur through the formation of ester groups. It is made by the interaction of a dibasic acid with dihydric alcohol. The presence of large aromatic rings in PET repeating units gives the polymer notable stiffness and strength, especially when the polymer chains are aligned with one another in an orderly arrangement by drawing, which is stretching. The raw materials for polyester include ethylene glycol, terephthalic acid, and a catalyst like zinc. Polyethylene terephthalate, or PET, is industrially produced by reacting terephthalic acid with ethylene glycol. The reaction starts at just above the melting point of the reactants in the presence of nitrogen. The ester exchange reaction is carried out under high pressure and a temperature of 200 degrees. The resulting low molecular weight ethylene glycol terephthalate is heated at 280 degrees for 30 minutes at atmospheric pressure so that the polycondensation reaction takes place. The pressure is removed from time to time to remove water. Polyester is thus obtained with a melting point of 256 degrees. The polymer is extruded from an autoclave onto a water-cooled casting wheel in the form of a thick ribbon. The polymer ribbons solidify on the casting wheel and are then cut into chips by a dicing machine. The wet chips are dried in air-operated rotary dryers. Polymer chips are discharged from hopper reservoirs to a spinneret. Polymer chips are melted at 260 degrees, and a delustering agent, lubricating oil, and anti-static agent are added to form a syrup-like solution. The solution is put in a metal container called a spinneret and forced through its tiny holes, which are usually round. The emerging filaments are cooled down, and solid filaments are obtained. The filaments are drawn at least 5 times to their original length, which increases their strength. The properties of polyester fibers include a tensile strength of medium tenacity, polyester filament at 80,000 pounds per square inch. High tenacity filaments have 8 to 11% elongation. Regular tenacity filaments have 15 to 20% elongation. At 2% stretch, it has 97% recovery, and at 4% stretch, it has 90% recovery. Polyester fabrics shrink 7 to 10% in boiling water. Polyester is almost hydrophobic with a moisture regain of 0.4% at standard conditions. It can be dissolved in trifluoroacetic acid, chlorophenol, and in a mixture of tetrachloroethylene. Polyester has good resistance to weak alkalis, and they are dyed with dispersed dyes in slightly acidic conditions. Polyester fiber has high resistance to degradation by light and is a very good insulator. Its uses consist of every form of clothing, home furnishings, ropes, nets, and even fiber fill applications.